Alright, so 6.2, properties of parallelograms. So our objective is to use relationships among the angles of parallelograms and the relationship among diagonals of parallelograms as well. Alright, so you just have to have the header at the top there. In this, we are going to write down a few things. We are going to write down what a parallelogram is. A parallelogram is a quadrilateral, 4 sides, with both pairs of opposite sides are parallel. So write down that one sentence. Draw this picture over here to the left right there, and you see that this side is parallel to that side, and this side is parallel to the opposite side right there. Okay, so have that, just that one sentence, that picture over there. And then on the side over here as well, we're going to write down this last thing. What is an opposite side or an opposite angle? So opposite sides, so you're going to write down this right here, this sentence and these two things. So opposite sides, they do not share a vertex. So it says AB, this one right here. The opposite side would be this right here. They don't share a vertex. And it's the same thing for angles. A and C are opposite angles, and it also would mean that B and D are also opposite angles. So we have opposite angles when they are on the same side or they're sharing it. That's what we call consecutive. So AB and AD would be consecutive sides. A and B would be consecutive angles, but when they are opposite of each other, that's when we call them opposite angles. And so we're going to use these definitions for some theorems that we have. So we'll write down some couple key concepts that we have next. Alright, so we're going to kind of go through these kind of quick, so if you need to pause the video anytime, you may, but make sure that you have everything inside the box and the picture as well written down. Oh, that's nice. You made it nice and bigger. Cool. Didn't even know how I did that. Alright, so the first one that we have right here is, it says, if a quadrilateral is a parallelogram, then the opposite sides are congruent. Let's see if I can move this down a little bit. Good, that's better. So we got 6.3. Okay, so what this means right here, though, is a parallelogram. The opposite sides right here are going to be congruent. The same thing with BC and AD. Those are also going to be congruent. So make sure you have everything in that written down. You may pause if you need to. If a quadrilateral is a parallelogram, then it's consecutive angles. Remember, consecutive means the same side. Then those are going to be supplementary. So we have A and B. When we add these together, they're going to equal 180. So anytime they're on the same side, they're always going to equal 180. Consecutive means on the same side. Okay. Which also means, though, in Theorem 6.5, that if they are opposite angles, then they are congruent. Remember, opposite means they are opposite of each other. So A and C are opposite, so those would be congruent. B and D are opposite, those would be congruent. Consecutive means same side. Okay, so I have everything in that picture written down. Next one is, if a quadrilateral is a parallelogram, then its diagonals bisect each other. Okay, so that means that if this is a parallelogram, and if we were to draw a diagonal line from A to C and A to B, then E right here is going to be our middle. Well, what's special about parallelograms is that this AE is going to be congruent to EC or CE. And the same thing applies to BE. That's going to also be congruent to DE. So kind of special when we have diagonals that bisect. Remember, bisect cuts it right there in half. And when these both come together, what's special is that the two sides are going to equal and be congruent to each other. Alright, and our last one, we're not talking about parallelograms anymore, but what we're talking about is parallel lines. So if three or more parallel lines, we have three lines right here, off congruent segments on one transversal. So what it means is that we have these three lines right here, and we see that these two are congruent, AC and CE. Well, what's going to be special with that, though, is then if they are cut by another transversal, then BD and DF are also going to be congruent. So basically means that like on opposite sides, if these two are congruent, then the opposite sides, these two as well, are going to be congruent. Okay, so just a few things. Make sure you have everything in those boxes written down, and we will do a few problems right now. Alright, so our first problem right here says, what is the measure of angle PN? And we have this symbol right here. This symbol stands for parallelogram. It looks like a parallelogram, and in math we like to always use some symbols sometimes, like we do a triangle symbol. We have this for the measure angle of P. This symbol right here stands for a parallelogram. So we have P, Q, R, and S, and this is a parallelogram. So we are trying to find the angle of P. Well, we know that P and R are opposite angles, and those are congruent, but we're looking, this points at S. So P and S are on the same side, so we say those are consecutive angles. And so we just got to remember, consecutive angles add up to 180 degrees. So if we know that angle S is 64 degrees, and we know that when we add that up with angle P, it's going to equal 180 degrees. In order to find this angle, we would subtract 64 to both sides, and we would get angle P right here is going to equal 116 degrees. Okay, so P 160, so my answer would be C right there. So the biggest thing is if they are on opposite sides, they're congruent. If they are same sides for a parallelogram, whether that's P and Q, P and S, or Q and R, those are consecutive angles. Consecutive angles are supplementary. Okay. Alright, so we got this problem right here. So it says solve for a system of linear equations to find the values of x and y in the parallelogram. That stands for parallelogram of KLMN, and wants to know what is the length of KM in LN. Alright, so we look at this. So we know that when we have a parallelogram and we have diagonals right there, when they come together, we know that this side right here is going to be congruent to this side, and we'll use a different color. Let's go sky blue. We know that this side right here is going to be congruent to this side. Alright, so this is going to be a little bit harder one because it's going to require us to do some algebra in order to find the lengths. Alright, so let's set this up. We know that it bisects it, so we know that the two sides are going to be equal to each other. So we have x is going to equal y plus 2. And we also know that y plus 10 is going to equal 2x minus 8. Alright, but we're looking at this. What we can't do though now is, because we have two variables, we have an x and a y, we can't solve for just one of them. So we need to get these to where they all have just one variable, and then we can solve it. So if you remember in algebra, when we had a system of equations, we used like two methods, elimination, and we also had substitution. So what we can do, substitution, is if we know x equals this amount right here, this is what x equals, what we can do is we can take this right here and we can plug it in for x right there. So let's do that. So we're using our substitution in order to solve. So we get y plus 10 is going to equal 2, and we're going to plug in what x equals, which is y plus 2, and this is going to be minus 8. So now we have all y's, now we can solve for y. So we still have y plus 10 equals, this is going to be 2y plus 4 minus 8. So we're going to get y plus 10 equals 2y minus 4. We get all, I'm going to add 4 to both sides. Add 4 to both sides. That's going to give me 14 equals, and I'm just going to subtract a y, a 1y from both sides, and so it's going to give me y is going to equal 14. Perfect. So we have y now. So I'm going to use a different color, see if we can squeeze it in. Let's go blue. So y equals 14. So we know what y equals. Now we just need to figure out what x equals. Well, I'm going to use this one right here where x is going to equal y plus 2. And we have x is going to equal, y was 14. 14 plus 2. So x is going to equal 16. So we have my x and my y value right now. And so if we want to solve now, it wants to know what is km and what is ln. So it wants to know what is the total length right there. So I'm going to erase, I'll keep this right here. Let's erase everything else. Give us some room to work with. Alright, there we go. Okay, so my last bit right here is if we know that x right here equals 16, so if I take 16 plus 16, that's going to give me 16 plus 16 is going to give me 32. So I know that right here ln is going to equal 32, and then that's for that one. And then let's use a different color. Let's use red right here. If I'm trying to find out what km equals, if I know y is 14, 14 right here, 14 plus 10 is going to equal 24. And if I know these two lengths are the same sides, all I have to do is take 24 and add it by itself or times it by 2. So 24 plus 24 is going to equal 48. So I know that km right here is going to equal 48. Alright, so it kind of required me to do a little bit more work. Those would be my answers right there. The biggest thing is when I set this up, I have to be able to solve for one of the variables, so I use substitution. Once I found what those were, I plugged them back in to find out what each of the side was. If I double the side, then I find out the full length of it. Okay, so that's probably one of our tougher problems right there, but I think we could be able to get it. Alright, we got one last one left. Alright, my last one says, in the figure, AE, BF, and CG, and DH are all parallel. And it tells me that AB is equal to BC, which equals to CD, which all equals 2. So if I'm looking at this, I know that each of these are going to be congruent, and they all equal 2. Well, we know that if these sides are congruent, then we know that these opposite sides cut by this transversal are also going to be congruent. So this EF is going to be congruent to FG, which is going to be congruent to GH, and it tells me that each of these is 2.5. So 2.25. So this is 2.25, which means that this side right here is also 2.25. So I want to know what is EH, the length of that. So all I have to do to solve for this one is 2.25. I could times it by 3, or I could just add up each of these sides together. 2.25 plus 2.25 is going to equal 6.75 right there. So that would be my final answer. Remember, if I have these are all congruent, then the opposite side right here cut by this transversal, these are also going to be congruent. Add them all together and I get 6.75. Okay? Alright, we'll do some more practice in class. Thanks for watching.